the gas evolved. If a gas is evolved in a reaction, it is denoted by an upward arrow. Example, Zn plus H2SO4 gives rise to ZnSO4 plus H2. 2. ZnS plus 2HCl L gives rise to ZnCl2S plus H2G. 4. Expressing precipitate form. If a precipitate is formed in the reaction, it is denoted by downward arrow. Example, AgNO3 plus NaCl gives rise to AgCl downward plus NaNO3, which is silver nitrate plus sodium chloride gives rise to silver chloride plus sodium nitrate. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. are indicated above or below the arrow in the equation. For example, 2AgCl S silver chloride in the presence of sunlight gives rise to 2AgS silver plus Cl2G chloride. 6CO2 Aq carbon dioxide plus 6H2O liquid water in the presence of sunlight and chlorophyll gives rise to C6H12O6 Aq glucose plus 6O2 Aq oxygen. Interpreting a balanced chemical equation. A chemical equation gives information about symbols and formula of reactants and products. Like symbols and formula, chemical equation conveys both qualitative and quantitative meaning. Let us consider an example. 2H2 plus O2 gives rise to 2H2O. This equation can be interpreted qualitatively by saying that hydrogen reacts with oxygen to form water. Quantitatively, the equation has number of meanings. Two molecules of hydrogen react with one molecule of oxygen to form two molecules of water. It also states that two volumes of hydrogen will completely react with one volume of oxygen to form two volumes of water. It gives information about relative masses of reactants and products. Let us consider another example. 2CuS copper plus O2 oxygen gives rise to 2CuO copper oxide. What information do you get from above equation? This equation tells us that copper reacts with oxygen to form copper oxide. The formula of copper oxide is CuO and that of oxygen is O2. 2 moles of copper atoms react with 1 mole of oxygen atom O2 to produce 2 moles of copper oxide CuO. Types of chemical reactions. When one or more substances, elements or compound undergo a chemical change with the absorption or release of energy so as to form one or more new products, then the change taking place collectively is called chemical reaction. In chemical reactions, atoms are neither created nor destroyed. Chemical reactions occur with the formation and breaking of chemical bonds. Various types of chemical reactions. 1. Chemical composition or chemical combination. 2. Chemical decomposition or chemical decombination. 3. Chemical displacement or chemical replacement. 4. Chemical double decomposition. 1. Chemical combination. When two elements react to form one new product or single product is formed from two or more reactants is known as chemical combination reaction. Activity 4. Take a small piece about 3 cm long of magnesium ribbon. Rub the magnesium ribbon with sandpaper. Hold it with a pair of tongs. Burn it with a spirit lamp or burner. What do you observe? You'll notice that magnesium burns in oxygen by producing dazzling white flame and changes into white powder. The white powder is magnesium oxide. 2 Mg plus O2 gives rise to 2 MgO. In this reaction, magnesium and oxygen combine to form a new substance, magnesium oxide. Such a reaction in which single product is formed from two or more reactants is the chemical combination. You'll also notice that the release of heat energy when magnesium burnt in air. Let us discuss some more examples of combination reactions. 1. Burning of coal. When coal is burnt in oxygen, carbon dioxide is produced. C plus O2 gives rise to CO2 plus Q heat energy. 2. Slake lime is prepared by adding water to quicklime. CaO plus H2O gives rise to CaOH twice plus Q heat energy. Large amount of heat energy is released on reaction of water with CaO. If you touch the walls of the container and you will feel the heat. Such reactions are called exothermic reactions. A solution of slake lime produced in the reaction equation 20 is used to whitewash walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. It gives shiny finish to the walls. CaOH twice plus CO2 gives rise to CaCO3 plus H2O. The chemical formula of marble is CaCO3 calcium carbonate. Do you know the respiration is an exothermic process? We need energy to stay alive. We get this energy from food we eat. During digestion, food is broken down into simpler substances. For example, rice, potato contains starch. The starch breaks down to form glucose. This glucose combines with oxygen in the cells of our body and releases energy which helps to do the various works. The special name of this reaction is respiration. It is an exothermic reaction. C6H12O6 plus 6O2 gives rise to 6CO2 plus 6H2O plus Q energy. The decomposition of vegetable matter into compost is also an example of an exothermic reaction. Formation of NO from N2 and O2. N2 plus O2 gives rise to 2NO. Decomposition reaction. Activity 5. Take a pinch of calcium carbonate limestone in a boiling tube. Heat the boiling tube over the flame of spirit lamp or burner. Now take a burning matchstick near the mouth of boiling tube. What do you observe? You'll notice that matchstick kept near the mouth of the boiling tube will be put off. In the above activity on heating calcium carbonate, it decomposes to calcium oxide and carbon dioxide. CaCO3 limestone in the presence of heat gives rise to CaO quicklime plus CO2. It is a thermal decomposition reaction. When a decomposition reaction is carried out by heating, it is called thermal decomposition reaction. In the above chemical reaction, the reactants absorb the energy to form the product NO. Reactions NO nitrogen monoxide which occurs by the absorption of energy are called endothermic reactions. Formation of HI from H2 and I2 is also another example of endothermic reaction. H2 plus I2 iodine gives rise to 2HI hydrogen iodide.